Welcome to the Math Record. Today we'll cover the CCML Geometry Contest 1 2015-2016 Division A. Let's just begin. An expressway entrance ramps up 400 feet over a horizontal distance of 480 feet. What's the ramp slope? So basically, let's just draw a picture of how it looks. So it's gonna look something like this. And horizontally, it will be this line length. The length will be 480, while the ramp rises up 40 feet. So slope is just rise over run. So it'll just be 40 over 480. That'll be 1 over 12. So this would be the answer, just 1 over 12. Pretty simple so far, just a basic slope question. Consider the diagram to the right for problems 2 to 4. Determine ray EA, right here, intersection with line CD, with array CD. So EA and CG. So we have line segment CE. So that's our answer. CE. Sorry. And the line segment. It looks like a line, but you have to put points in it. So, or you just write CE. That's fine either way. Determine line CD right here, a union CE and DE. Three lines together that intersect at three different points make a triangle. It's called triangle CDE, or like triangle EDC, or whatever way. It just has to have these three letters. So it just has to have these three letters. So it's basically that simple. Question 4. Angle AEF is 120 degrees. Determine angles DEG. Since this line and this line are intersecting, that means these two angles are vertical. Since they're vertical angles, that means they have to be identical angles. So AEF is 120. So DEG also has to be 120. It's just a basic angle property. So if you just know it, you know it. Compute the distance between points -1, 0 and 3, -3. So the distance between 2 points is that you gotta look for the triangle. So what you're gonna do is, like, let's just make a triangle first. If you could create a picture, you might just want to create a picture. So it's at -1 to 3. So the distance between -1 and 3 is 4. And the distance between 0 and -3 is 3. This picture is not the same thing, so this is just a 3, 4, 5 triangle. Or you could just like prove it with using the Pythagorean Theorem. Sorry. Squared is equal to like hypotenuse squared. So that's 16, that's 9, that's 25. Square root 25 gets h. That's 5. So the answer is just 5. So the distance is just 5. Really just that simple. If you want a more realistic picture, it will be something like this. It will be -1, 0, so it's gotta be somewhere here, and it's gotta be 3, -3, so somewhere right here. So I can't draw points with this. So you make like a line right here. So this would be -1 to 3, so that's 4. And this would be 0 to -3, so that's 3. So the distance between them is just 5. Because this is a right angle. So that's how it looks. So you could draw a picture to get a more comprehensive idea than just do that. But usually it's pretty simple if it's just like the distance between 2 points. Question 6. Two supplementary angles have measures x and y, where x is 5 times as large as y. Determine y in degrees. So two supplementary angles. So it must be x plus y is equal to 180, because that's the definition of a supplementary angle. Now, it also says right here that x is 5 times as large as y. So x is 5y. So substitute x in, you get 6y is equal to 180. So y is equal to 30 degrees. So y is just 30 degrees. It's just that easy. So you just need to know your definition of supplementary angles. There's supplementary and there's complementary. Supplementary is I'm just not gonna write the entire thing, is 180 degrees. Like the sum of two angles has to be 180, or like the angles has to be 180. It doesn't have to be two. And there is I think it doesn't have to be two. And complementary angles are 90 degrees. So supplementaries make a line. Complementaries make a right triangle. Might make a right angle. Question 7. How many positive integer factors does 360 have? There's a formula for this. It's the easier way how I do it. So what you do is that you want to factor down 360 first. So you get 360 is 2 and 180, and then factor that down. I usually use 2 if it's even. So it's 2 and 90 again. 2 and 45. And 45 is just 3 times 3 times 5. So overall, this thing is just 2 to 2 times 3 to 2 times 5 to 1. So basically what you do is you add 1 to each of the exponents. So that's a 3, that's a 3, and that's a 2. And you multiply them all together. So that's 9, and that's 18. And, wait, did I miss one? Oh, sorry, it's 2 to the 3. 2 to the 3, 1, 2, 3, 3 twos, times 3 to the 2, times 5 is equal to 360. Now you just add 1 to each one, so that's a 4, that's a 3, that's a 2, so that's 12, and that's 24, and that's the answer, basically. Basically, if you think about it logically, the only ways you could multiply to like different factors out of 360 is you could have, let's say you have one of the twos, or you could have two twos, or you could have three twos, and you could have those in combination with three, 1 3, 1 5, or 1 3 and no fives, two threes and like 1 5, and two threes and no fives. And you could have like 1, 2, or 3 twos. And you could do the same thing for threes and the fives. And that's why there's 24 combinations. Because there's 4 ways to go here, 3 ways to go here, and 2 ways to go here. Because 0 is also a possibility. Because 2 to 0 is also just 1. So like 2 to 0 times 3 to 0 times 5 to 0 is just 0 is just 1, which is also one of the factors. So it gives you different numbers every single time. So 24 would be the answer, which is just that easy. Um, uh, Solve for y. Number 8. 2y squared minus 1 plus y is equal to 0. So I'll get 2y plus y minus 1 equals 0. So what I usually do is, since this is 2, I'm just going to put 2y, and then put y here. So the only way to get to negative 1 is just negative 1 and 1. So since this is positive, I want to keep the 2 as positive. So I'll put plus 1 here, and then minus 1, which is true, because that's plus is 2, that's minus 1, so that's plus y, and that minus 1. So this all works out. So the answer for this is y is negative 1, and y is equal to 1/2. And that's what you do. And that's what you do. Usually when I write these answers, since I don't know if I could write or and, like if it's 1/2 or negative 1 or 1/2 and negative 1, what I usually do is just write 1/2 comma negative 1. Because it kind of, this is also another way you could write the answer. Because sometimes people are just a stickler how it like is written. Question 9. Consider points A01 and B25. Give coordinates of the point that lies on AP that is 3 times as far from A as it is from B. So let's kind of like draw this point out first. So you don't really have to draw the graph. So what you do is that you have a point right here, and we'll call this A. So this is at 0, 1. So if you think about B, that'll be at 2, 5. So you're gonna have to move 2 over and 5 here. So we have something like B. Okay, draw the line. You really don't have to draw the coordinate plane. So what you want to do is that the point on AB, this line, is 3 times as far from A as it is from B. So it's got to be right here. So this is 3x to x, right? Or the distance, not x. Like x is just where the points are. So that means this is that means the total distance has to be out of 4, because 3 plus 1, so that's 4. So that'll be out of 4. So if you think about it, you gotta draw the shape. So from 0 to 2, because that's where the distance is from the x coordinate, is 2. and the distance from the y-coordinate is 1 to 5, so that's 4, right? So if you want to get to this point right here, you gotta have to go to 3/4 of the distance, right? Because this is 3x. You have to do 3/4. This is 3 out of the 4 in total. So if you think about it, that's 2 times 3/4, and that's for the x, and y would be 4 times 3/4. So this one is moving 1.5, and this one's moving 3. So you add that to position A to get 1.5. Sorry, my handwriting is bad. 1. Really, my handwriting is bad. 1.5 and 1.5 times 0 plus 0 is just 1.5, and 3 plus 1 is 4. So that so so this would be the new coordinate. You can also write this in fraction form, like 3/2. So that's fine either way. But that's how you usually find the answer. You just draw a picture. A lot of geometry, the contest for geometry, you basically just draw a picture. Question 10. In the diagram to the right, O and E are transection points of WM. So this is like X, X, and X. X is a distance. So X is like W0, 0E, and EM. So MOT, two of the triangles, have an area of 6. Give the sum of the areas of MET and W and wait, MET and WOT. So it just wants these two areas. So if MOT, right, is an area of 6, because I'll draw this out for you, right? I rotated the graph a little bit. So basically, they're saying MOT, so let's say this part is MOT, right, is an area 6. Since these two, like, sides are exactly the same, and these two has the same height, technically both of these areas would be 3. Since this is the same case here, this will also be 3. So they're asking for the area of MET plus the area of WOT is basically the exact same thing as like MOT just by itself, because they're all the same trisection points, so the base would be the same, but the height is also the same. So basically the area is just 6, because it's just this part plus this part. So pretty interesting question. Not really mathy, but like if you just think about it, you get it right. A rectangle has side lengths 15 and 29. Another has side lengths that are triple those of the first rectangle. Compute the ratio of the larger area to that of the small area. Okay, this is really basic. You really don't need to focus on the side length. If they ever ask you that they're like similar, like shape, like any similar shape, the ratio would always just be like basically what the side length is squared. So just think about it. Let's say your side length is x, your length are x and y, right? And this one is a 2x, and this one's 2. Why did I write? Sorry, I wrote x twice. X and y. Then this one would be 2x, and this would be 2y. And the area of this would be xy, and this would be 4xy. You know, you see how this is 4 times? Whatever the side length is, you just square it. So if this is triple of that, that means the ratio of this to the smaller one, it doesn't look like it's smaller, but it is, would be just 3 squared. So it's just 9. The answer is really just that basic. Like I could do another shape like similar to like I'm just gonna use a right triangle because it's easier. We'll call this x and we call this y, and we'll call this 2x and this is 2y. So the area of a triangle is x times y divided by 2, and this area is 2x times 2y, which is 4xy divided by 2. So this would just cancel out to a 2, and this would be 1/2. So what is 2 to 1/2? 2 divided by 1/2 is 4, which is the same thing as just 2 squared, which makes sense. So kind of tips and tricks. You really don't have to do all the calculations like look for the hypotenuse or stuff. I don't know what you need to look for this, or like the area, which takes too long time just for like 50 minutes. to like work on this entire contest. 12. Let the maximum number of elements that are divisible by 4 in a set of let x be the maximum number of elements that are divisible by 4 in a set of 9 consecutive integers. Let n be the minimum numbers of elements that are divisible by 4 in a set of consecutive 9 integers. Okay, so let's do this. Let's just draw out the position 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this will be number 1. This will be let's just draw this out. 2, 3. Write this out. 3, 4, 5, 6, 7, 8, 9. See, these are 9 consecutive integers. So this will be like, you know how this add by 1, or it could be like 2, 3, 4, 5, 6, 7. It doesn't have to be these numbers. I'm just using these as placeholders for like, this will be the first number, this is the second number, this is the third number. Okay? So let m be the maximum number of elements. So if you think logically, the only way for it to have a maximum number of elements is if it starts out divisible by 4, because then it could have like more later on, because every single 4 numbers will give you another divisible of 4, basically. So if you start like at the second one, you start with divisible by 4, you're kind of shifting the place over. Like think of a number line, and you choose like a set of 9 numbers, and you're shifting your place over, then basically you're just lowering the amount of 4s you could get. So you have to start with the highest 4. So if you have a 4 here, that means this one's a divisible by 4. So 1, 2, 3, 4. So this one's also divisible by 4. 1, 2, 3, 4. So this is also divisible by 4. So the maximum amount, sorry, I can't write. Maximum amount is equal to 4. I mean equal to 3, because there are 3 maximum that are divisible by in a set of 9 consecutive integers. Let y be the minimum number of elements that are divisible by 4 in a set of 9 consecutive integers. So let's say that's x. Okay, so we need to find the minimum amount for 4. So let's just do like something from the second, right? So if we have 4 here, that means 1. Actually, if we want to minimize it, we want to subtract as many possible out. Because you know, if this is 4, then if I have like a 4 here, then only 1 is out. But if I have 4 here, then 2 is out. If I have 4 here, then 3 of them are out. But if I have 4 here, there's already a 4 here, so I can't do that. So the maximum amount that I can subtract out is the 3. So you just think about it. So that's 4. Now, like the same idea as this one, every single 4 is divisible. So 1, 2, 3, 4, 4. So the minimum amount that you can have of a 4 is 2 for y. So the max minus min, which is x minus y, is just 1. So pretty cool question. You just had to like think about it and make like this kind of like number system. I would personally use this way too. So, and number 13. A triangle has side lengths 10, 24, 25. Classify the triangle as acute, right, or obtuse. So what you use is that you always use the Pythagorean theorem. So you have 10 squared plus 24 squared, and you compare that to like 25 squared. So 10 squared is 100. 24 squared is, give me a calculator. I think it's like, yeah, 576. And 25 squared is 625. So since 100 plus this is 675, which is greater than 625, what it tells me is that it's gonna be acute. Because like if you just draw the triangle out, right? Let's just imagine like 10, 24, and 25 is a right triangle. So you have a 10, you have a 24, and you have a 25. This is not a right triangle, but like just imagine first it is. If 10 plus 24 plus 25, 10 squared plus 24 squared is equal to 125, right? And 125 is like less than 765, which is what it really adds up to. That means the hypotenuse has to be big, has to be like some kind of like uh you know how do I like explain this? So it will be like if this is 675, then what I need to do is that I need to kind of like lessen this, you know? You just gotta think about it. So it's something like that. And I just need to like take that out somehow. you know. So that's what I really had to do, because then like if I want to make this as big as possible, like I need to like move it away, because then like you can't have something like this, because then it wouldn't make sense, you know. Because if this is 25, how am I supposed to make this one bigger? Because like this one is already bigger than this one. So the only way to make it bigger is that like instead of moving this line out, which is this one, I have to move this line in and kind of increase the height. So I will be like right here is 10, the 24, like line here has to move in but gets kind of taller. So it gets taller, it decreases the length but it increases the height. So it does like that. And then the height can also so this is the 25 and it can also decrease in length like this in this slide, and then it would just increase in height. So able to get 25 and this will be able to get 24. Then that's why it's going to be acute. Or you can also just remember the rule that if you use a side length x squared plus y squared, which is the side length, is greater than the last side length, then it's going to be acute. If it's x squared plus y squared is equal to the side length, it's right because of the Pythagorean Theorem. And if x squared plus y squared is less than the side length, it's going to be obtuse. So you just do something like that if you just want to memorize it, which is good too, which saves like a lot of time. Okay. So the answer was acute, if you didn't catch that earlier. Number 4, recall that a minute is 60th of a degree and a second is a 60th of a minute. Thanks a lot, ancient Babylonians. Okay, cool. Convert the quantity 12 degrees. 30 minutes is usually represented by like a quotation mark, and 12 seconds, which is 2 quotation marks. I mean like yeah, whatever they're called. Into degree only. So they already said it right here, so just do the conversion. What you usually do is just it's 12, the first one, plus 30 over 60, plus 12 over 60 squared. So if you have another one, like let's say like 13, 1, 2, 3, it's gonna be like 13 60th cubed. You know? So that's basically how you do it. I'm not gonna do this by hand, I'm just gonna use the calculator. So you get 12 plus 30 divided by 60 plus 12 divided by 60 squared. You get like sorry, I calculate cannot do fraction form. What does this get? 12 plus 30 divided by 60 plus 12 divided by 60 squared. And you get 3,751 over 300. So that would be the answer in like improper. I would usually just leave it right here because if you have a calculator, you really don't want to do the conversion because you might write it out wrong in mixed fraction. Since this is already the answer, like what's the point of like spending time to like make it into like a different answer that's equivalent, you know? So that's 14. Question 15. A given angle has measure x. What's the measure of the supplement of the complement of the angle? So, okay, we gotta dissect this first. So it says, what's the measure of the supplement of the complement of the angle? So the first thing we do is to find the complement of the angle. So the angle is the complement of x would be 90 minus x, like what I explained earlier. It's just x plus another angle has to be equal 90 for it to be complement. So it'll be 90 minus x the other one, which makes sense because 90 minus x plus x is 90. So what's the measure of the supplement of the complement of the angle? So the supplement of this angle would just be this angle plus another angle is 180. So it'll be 180 minus this angle, which is minus 90. And then a negative is positive. So that's like this. So what do we get in 90 plus x? So this will be the answer, 90 plus x. You're not going to get like an actual like answer, like 200. This is not going to like, I mean, not 200. That's bigger than 180 of like 45 because it's not going to work because you don't have a degree measure already given. Question 16. Consider the square to the right. The dark region shows the intersection of two quarter circles. Like there's a circle right here, and then make another intersection right here, and these two intersect right there. With the radius equal to the edge of the square. Determine the ratio of the dark area to the ratio of the area. So what I want to do first, let's just draw a picture of like one of the circles first. So let's say the circle is like this, right? And you have to look for this area. So let's just use side length 1 because it would be easier. So the area of a quarter of a circle, the area of a circle is pi radius squared. So since the radius is 1, the area is just pi, but a fourth of it is fourth. So pi over 4. But the area of a rectangle is 1, so it's just 1 minus the square is 1 minus pi over 4, which gives pi over 4 is this area. So what this thing gives us, 1 minus pi over 4, gives us this area. So this blank area. So since this area is the same as this area, like they're both the same, because if you just draw the other circle like this, then this area is just basically the same thing. It's just rotated. And if you draw this one on top of that one, you just get these two areas. So these two area is exact. So this area is exactly the same. So you just multiply by 2. So you get 2 minus pi over 2. And then since this area is already 1, you just have 1 minus 2 minus pi over 2. So you minus 2 plus pi over 2. And you get pi over 2 minus 1, which is the area of the dark. So if the area of the dark is pi over 2 minus 1, and the area of the square is 1, then it's just this. This is the area, which is just pi over 2 minus 1. So it's really just that simple. Just draw a picture. Oh, sorry. So just draw a picture and you'll be fine. So that is question 16. Like, I know this because I've seen this type of question before. It's one of the common ones that you find area to find the relationship. A triangle has side lengths 5, y, and z, where y and z are randomly chosen for 4, 5, 6, 7, 8 without replacement. What is the probability that the triangle is scalene? Without replacement. So if it's without replacement, y and z cannot be the same if you think about it, because there's only 4, 5, 6, 7, 8, and those, if you choose one of them, you can't choose another one that's exactly the same. So if you choose 4, you can't choose 4 again. So the only way for it to be other than scalene would be like if it's equilateral or if it's isosceles. So the only way for it's isosceles, since this is already a 5, then we need to somehow like get a 5. And the only way for equilateral is that they're all the same thing, which doesn't make sense because y and z is not going to be the same. So the only case is when y or z gets 5. So what's the probability of getting out of the 5 numbers for like y first? Like what's the probability of just getting something other than 5, which is 4 out of 5. And now we need to choose something for z. So what's the probability of getting something that's not 5 if one of them is chosen? So let's say 4 is chosen, right? We can't have this 5, so we have 3 out of the 4 left. So we have 3 over 4. And the answer is just 3 over 5, which is really just that basic. So that's the answer, 3 over 5. Question 18. A sequence of right triangles is created as follows. The first triangle has side length 1, 1. And the second one has the length of a triangle 1 and a leg that's hypotenuse of this one. So it makes another one like right here later on. Process continues each time using a length of 1 and the length that was the previous triangle's hypotenuse. Which triangle in the first sequence whose two longest legs differ by less than 1/10 in length? So what we're just gonna have to like look for this actually. So we're gonna have the first one is 1, 1, right? So a 1, 1 triangle would make a hypotenuse of square root 2. And then we have something of square root 2 and 1. So that's 2, that's 1, that's square root 3. So then square root 3, and then that's also 1, makes 3 and a 4. So that's square root 4. I'm not going to simplify it. You see how the pattern's going? It goes by square root 2, square root 3, and square root 4. The longest one will always be the one before it. So what you're going to look is square root x. We're going to have, this is the number, minus square root x minus 1. Because these are the two longest. So it'll be this side length and this side length. So then, which triangle in the first sequence? Okay, never mind. Actually, let's actually like put this in the right variable. X plus 1 minus x. Because this would be like, this is the third triangle. Because then if this is the third triangle, then this is 4. So you subtract it. And it has to differ by this thing has to be less than 1/10 in length. So what you kind of want to do is that you kind of just want to use your calculator and just start spamming it. So you just put square root like 6 minus square root 5. Nope, it's not gonna work. Square root 10 minus square root 9. Nope. And square root 20 minus square root 19. Nope. Square root 25 minus square root 24. Square root 30 minus square root 29. Okay, so square root kind of 30 works, so let's start going down. So square root 29 minus square root 28. Square root 27, square root 26. Square root 26, square root 25. And then we have back to square root 25 minus square root 24. Since the lowest, since the first one that was the square root 26 minus square root 25, that means the first triangle has to be the 25th, because x was 25 and that makes 26. So that was the first time it became less than 1/2. That would be the first that's what answers this question. Which triangle is the first in the sequence who's differ by that? So it'll be 25. So it's a pretty cool question. You just have to list them out. Don't simplify it like how I did with square root 4. So far, this would be like the hardest question, I guess, but it's also really easy if you just think about it. But it's also one of the more interesting ones. You have a cube with an edge length of 100 centimeters, and paint costs 0.001 dollars per cubic centimeter. If you fill the interior of the cube with paint, it would cost X dollars. If you were to paint the all 6 exterior faces of the cube with a layer of Y centimeter, with a layer XY centimeters thick, it will cost $988 less. Determine why. Okay, so we first have to find out the X dollars, which is if you fill the interior. So it would just be 100 cubed because each length is 100. So 100 cubed times the cost, which is 0.001. So that will be our cost. So let's use our calculator to find out what that is. So 100 cubed times 0.001, you get 1,000. So it's going to be $1,000, right? So if you were to paint the all 6 exterior faces, so there's 6 exterior faces with a layer Y centimeter thick. So what's going to be is that it's going to be like some kind of rectangular prism or square prism or whatever it's called. So it's going to be the length and width would be 100 because it's going to be like, let's say a cube like this, right? Can you draw a picture? Let's just draw out this side length. So it'd be like that. And we're going to draw. So it's going to be like something like this. So they're making that. So what we're going to do is we have this and this, which gives us 100 squared times the which is Y centimeters thick. So you multiply times Y. And then you find the cost, which is times 0.001. And this cost is 900. It will cost $988 less for this one. So you minus 988, that gets you $12. So that equals 12. So we just need to solve for y. So we have 12 divided by 0.001 divided by 100 divided by another 100. You get the y as 1.2. Wait, did I write that wrong? Wait, 988. So, what? Wait, let me recheck my math first. it has an edge length of 100, and so that the volume is 100 cubed times this for every cubic centimeters will cost us dollars. Sorry, that I'm just looking at the answer key and saying why this is wrong. So one, I'm double checking. That's 1,000. If you were to paint all 6 exterior side, like, oh, okay. I'm sorry. This is only for one of the faces. So for 6 of them, you have to multiply by 6. So you have 12 divided by 6 divided by 0. Then divided by 0.001, then divided by 100, then divided by 100. So y is equal to 0.2, which is the answer. Sorry about that. So in this question, I guess is kind of tricky because I got it wrong the first time also, but it's not really that hard. You just gotta keep track of all your information. Like I said, like most of the geometry just draws a picture, like how I did before to find like show you how it looks. But I guess you should be able to figure it out. Question 20. You have a bag that contains 2 distinct 0-point cards, 3 distinct 1-point cards, and 2 distinct 2-point cards. You are playing a game in which you could draw up to a maximum of 4 cards, and the goal is to get a total score of exactly 3 points. How many ways are there for there to win? Note the order of selection of cards is unimportant. Okay, so you have 2 distinct 0-point cards, 3 distinct 1-point cards, and you have 2 distinct 2-point cards. And the goal is that you could get up to 4 cards. So up 4. But you have to score 3. So you have to score 3. Up to 4. Okay. How many ways are there to win? So the order of selection is unimportant. Okay. So basically they're trying to say since the order of selection is not important, it doesn't matter if it's 0, 1, 2, and then 0, 2, 1. 0, 2, 1. Because this will be the exact same. This will count as only one combination. So the only way to add up to 3, let's say we use the lowest numbers, is 1, 1, 1, which is the only way to make up to 3. And then another way would just be 1 and 2. And those are the only ways to add up to 3. Since there's zeros, we can add it. Since it's only up to 4 cards, but we have 2 zeros, we have 1 0 here, but there's 2 probabilities here. And there's this can have up to 2 more zeros. So how many ways can we get just like these triple threes? Well, there's only one way because you have to get all 3 cards. You can't have like 2 of the 3s, you know? Like it doesn't make sense. So the only way to get 3 of the 3s because you could get up to 4 cards. So if you only get 3 cards, you have to get all these 3. So if you want to get all these 4, you had to get this one plus these 2 others. So that's 1 times 2 because there's 2 possible zeros. Because this is equal 1, 2, 3. This 4, or it could be these 3 and this 1. So that makes there's 2 more combinations. So how many ways can you get 1 and 2? There's 3 here and there's 2 here, and you just need 1 of each. So that's 3 times 2 is 6. So how many ways can you get 1, 2, and just 1, 0? So that's this, and this. So it's just 2 times 3 times 2, which is 6, 12, which is 12. And how many ways can you get 1, 2, 0, and 0? So you need 1 of this, and 2 of this. So there's only you have to get both these. So that's only counts as one combination. So that's gonna be 2 times 3 times 1. So that would be 6. So adding up together, 12 plus 6 plus 6 plus 2 plus 1. Let's just add this portion first. So that's 12. That's 24. That equals 3. So the answer is 27. So that's the total amount of combinations. Pretty interesting question. It's one of the harder ones. Probably the hardest one, actually. But if you just write out your combinations, you should be fine. So that was the CCML Geometry Contest 1 2015-2016 Division A, which is Calculator OK because it's Contest 1. Thanks for watching the video, and I'll see you at the next math record.